Time travel, Stephen Hawking and the possibility of traveling to the past. Hawking was one of the first to explain the possibility of time travel in his theory. Could time travel be a reality? This video explores Hawking's views on time travel and whether we can actually change the past. Time travel has long captivated the imagination of humanity, inspiring countless works of fiction, fueling scientific debates, and prompting us to ask some of the deepest questions about the nature of reality itself. Among the many brilliant minds who have grappled with the mysteries of time, few have approached the topic with the clarity, rigor, and insight of Stephen Hawking. Renowned for his contributions to cosmology, quantum gravity, and our understanding of black holes, Hawking also turned his attention to one of science's most tantalizing questions. Is time travel possible? And if so, could we ever journey into the past and change the course of history? To begin exploring Hawking's perspective, we must first understand how time is viewed in the context of modern physics. According to Einstein's theory of relativity, time and space are not separate entities, but are woven together into a single fabric known as space-time. This four-dimensional construct bends and warps in response to the presence of mass and energy. In everyday life, we experience time as a steady, unyielding flow, moving inexorably from the past through the present and into the future. But the equations of relativity suggest that time is far more flexible and mysterious than our senses perceive. For Hawking, the possibility of time travel arises naturally from the mathematics of general relativity. In his famous book, A Brief History of Time, he describes how certain solutions to Einstein's equations allow for the existence of so-called closed time-like curves. These are loops in space-time that, at least theoretically, allow an object or person to travel back to an earlier point in time. The concept is dizzying. Imagine walking in a circle, but instead of returning to your starting point in space, you return to your starting point in time. One of the earliest and most famous examples of a closed time-like curve can be found in the work of Kurt Gödel, a mathematician and friend of Einstein. In 1949, Gödel discovered a solution to Einstein's equations that described a rotating universe where time travel to the past was, in principle, possible. However, this solution depended on properties of the universe that do not match our own, such as the universe rotating as a whole. Nonetheless, it opened the door to further theoretical exploration. Hawking was fascinated by these possibilities, but he was also deeply skeptical. He was aware of the paradoxes that time travel to the past would introduce. The most famous of these is the grandfather paradox. Suppose you travel back in time and prevent your grandfather from meeting your grandmother. If you succeed, you would never be born. Yet if you were never born, how could you have traveled back in time in the first place? Such paradoxes challenge our understanding of causality, the principle that cause precedes effect. To address these concerns, Hawking introduced a concept he called the chronology protection conjecture. According to this idea, the laws of physics conspires to prevent time travel to the past, thus safeguarding the consistency of history. In other words, while the mathematics of relativity might allow for time travel, some deeper as yet undiscovered laws of physics might intervene to prevent it from actually occurring. But what mechanisms could prevent time travel? Hawking pointed to the role of quantum effects. When we try to create a time machine, for example, by constructing a wormhole that connects two points in space-time, quantum fluctuations might become so intense near the mouth of the wormhole that they destroy it before anything can pass through. The very attempt to manipulate space-time in this way could unleash destructive energies that render time travel impossible. Despite these obstacles, Hawking remained open-minded. He famously held a party for time travelers, sending out invitations only after the event had occurred. The idea was simple. If time travel to the past is possible, future time travelers would receive the invitation and show up at the party. No one came, which Hawking took as evidence, albeit tongue-in-cheek, that time travel to the past is not possible, or at least not practical. Yet the theoretical possibilities remain tantalizing. Physicists have explored a variety of mechanisms that could, in principle, allow for time travel. One of the most intriguing involves the concept of a wormhole, a hypothetical tunnel connecting distant points in space-time. If such a structure could be stabilized and manipulated, it might allow for shortcuts not only through space but also through time. However, constructing and maintaining a wormhole would require exotic forms of matter with negative energy, a substance that has never been observed and may not exist. Hawking's approach to the question of time travel was characterized by a blend of curiosity, skepticism, and scientific rigor. He recognized the allure of the idea, but he also understood the immense challenges involved. For Hawking, the key to understanding time travel lies in the interplay between relativity, quantum mechanics, and thermodynamics. One of the most profound insights in modern physics is the realization that the universe has an arrow of time. This arrow points in the direction of increasing entropy, a measure of disorder. In everyday life, we see this in the way that eggs break but never spontaneously reassemble, or how ice cubes melt but never refreeze without intervention. The laws of physics themselves are, for the most part, time-symmetric, meaning they do not distinguish between past and future. But the increase of entropy gives time its direction, making the past fundamentally different from the future. Hawking argued that this arrow of time is closely tied to the expansion of the universe and the behavior of black holes. As the universe expands, entropy increases, and the flow of time moves relentlessly forward. In black holes, the inexorable pull of gravity leads to the formation of an event horizon, a point of no return beyond which nothing, not even light, can escape. Inside a black hole, the conventional rules of time break down, and space and time swap roles, leading to some of the most bizarre and counterintuitive predictions in all of physics. Could black holes or other exotic objects provide a pathway to the past? Some theoretical work suggests that rotating black holes, known as Kerr black holes, might contain ring singularities that allow for closed time-like curves. But the intense gravitational forces and radiation near such objects would likely destroy any would-be time traveler long before they could complete their journey. Hawking also considered the implications of quantum mechanics for time travel. In the quantum world, particles can exist in multiple states at once, and events can be fundamentally unpredictable. This led some physicists to speculate that time travel might be possible if the universe splits into parallel timelines whenever a paradox arises. In this scenario, traveling to the past does not alter your original timeline, but creates a new alternate history. Hawking was skeptical of this idea, arguing that it raises more questions than it answers, and that there is no experimental evidence to support it. Despite these challenges, the quest to understand time travel has driven significant advances in physics. Research into the nature of space-time, the behavior of black holes, and the unification of quantum mechanics and gravity continues to push the boundaries of our knowledge. While time travel to the future is, in a sense, already possible, thanks to the effects of time dilation and relativity, the dream of returning to the past remains elusive. Time dilation occurs when an object moves at speeds close to the speed of light or is situated in a strong gravitational field. For example, astronauts on the International Space Station age slightly more slowly than people on Earth due to the weaker gravity and higher speed. This effect has been measured with atomic clocks and is a well-established consequence of relativity. In a sense, these astronauts are time travelers, moving into the future at a slightly accelerated rate. But traveling to the past is a much more daunting challenge. Throughout his career, Hawking balanced the allure of time travel with a deep respect for the laws of physics. He delighted in the paradoxes and puzzles that time travel presents, but cautioned against assuming that theoretical possibilities necessarily translate into physical realities. For Hawking, the beauty of science lay in its ability to reveal the underlying order of the universe, even, or especially, when that order defied our everyday intuition. One of Hawking's most famous public statements on time travel came during a lecture at the University of Cambridge. He said, "If time travel is possible, where are the tourists from the future?" This rhetorical question highlights the absence of evidence for time travelers in our midst, despite the theoretical loopholes that physics might provide. It also underscores a central tenet of scientific inquiry: extraordinary claims require extraordinary evidence. In the final analysis, Hawking's views on time travel reflect a profound humility before the mysteries of the universe. He acknowledged that our current understanding of physics is incomplete, and that future discoveries might upend even our most cherished assumptions. Yet, he also insisted that any theory of time travel must be grounded in the rigorous mathematics and experimental evidence that define the scientific method. For those who dream of changing the past, of undoing mistakes, reliving cherished moments, or reshaping history, the prospect of time travel remains both tantalizing and fraught with peril. Hawking warned that the consequences of altering the past could be catastrophic, leading to paradoxes and contradictions that undermine the very fabric of reality. He suggested that the universe may have built-in safeguards to prevent such tampering, ensuring that the past remains fixed and inviolate. Yet, the human fascination with time travel endures. It speaks to our longing for control over our destiny, our desire to understand the nature of existence, and our willingness to challenge the boundaries of what is possible. Hawking's work serves as both an inspiration and a cautionary tale, reminding us that the universe is stranger and more wondrous than we can imagine, and that the search for knowledge is itself a journey through the fabric of time. As we look to the future, the quest to unravel the mysteries of time continues to drive scientific discovery. Advances in quantum gravity, string theory, and the study of the early universe may one day shed new light on the possibility of time travel. For now, the dream of journeying to the past remains just out of reach, a challenge for future generations of thinkers, explorers, and dreamers. In reflecting on Hawking's legacy, we are reminded that the pursuit of knowledge is an endless adventure, one that spans the ages and bridges the gap between science and imagination. Whether or not time travel to the past is ever realized, the questions it raises illuminate the deepest mysteries of existence and inspire us to probe the limits of what is possible. The legacy of Stephen Hawking endures not only in his scientific achievements, but also in his willingness to ask bold questions and confront the unknown. His explorations of time, space, and the nature of reality continue to inspire scientists and lay people alike, inviting us to ponder our place in the cosmos and the secrets that lie hidden within the fabric of time. As we contemplate the possibility of time travel, we are drawn into a realm where science and philosophy converge, where the known and the unknown intertwine, and where the boundaries of reality blur. Hawking's insights remind us that the universe is a place of wonder and mystery, and that the pursuit of understanding is itself a form of time travel, a journey through the unfolding story of existence. In the end, the question of whether we can travel to the past remains unanswered, but in seeking the answer, we embark on a voyage of discovery that enriches our understanding of the universe and ourselves. Whether or not time machines ever materialize, the true value of the quest lies in the questions we ask, the mysteries we explore, and the horizons we seek to expand. The story of time travel, as seen through Hawking's eyes, is not just a scientific puzzle, but a testament to the power of curiosity, imagination, and the relentless human spirit. As we continue to explore the frontiers of knowledge, we honor his legacy and keep alive the dream of one day unlocking the secrets of time itself.